Welcome aboard to Ship's Tech Talk, your go-to destination for all things maritime technology. In today's episode, we delve into the intricate workings of incremental encoders, essential devices that steer the course of precision in ship systems and beyond. How does radar determine the direction of its targets? You are viewing an incremental rotary encoder attached to the gear wheel of the scanner antenna shaft of a Furuno FAR 2157 radar. Rotary encoders are used to determine the angular position of a rotating shaft or object. In radar systems, they can be used to measure the azimuth and elevation angles of antenna arrays. This incremental rotary encoder provides the azimuth angle and rotating speed of the radar antenna to the control system, which helps to determine the direction of the received echoes. The working principle of incremental rotary encoders. An incremental rotary encoder generates electrical signals in response to rotational movement. The components of an incremental encoder are encoder disk. This is a circular disk with evenly spaced slots or lines around its circumference. The slots or lines are the encoding elements that interact with the encoder's sensors to generate signals. Light source and sensors. Incremental encoders typically use light-based sensing mechanisms. They have a light source, often an LED, and sensors placed opposite to each other on either side of the encoder disk. Signal processing circuitry. The signals generated by the sensors are processed by electronic circuitry within the encoder to produce digital output signals. Working steps. As the encoder disk rotates, the slots or lines on the disk interrupt the light beam between the light source and the sensors. The interruptions cause the sensors to detect changes in light intensity. Each interruption generates a series of electrical pulses in the sensors. The number of pulses corresponds to the number of slots or lines on the encoder disk. Many incremental encoders use a quadrature output scheme, where two sensors are offset from each other by 90 degrees. This arrangement produces two sets of pulse trains, called A and B channels, with a phase difference of 90 degrees. Analyzing the phase difference allows the encoder to determine both the direction and speed of rotation. In addition to the A and B channels, incremental encoders often have an index pulse channel. This channel generates a pulse once per revolution, indicating a reference point or home position. The resolution of an incremental encoder refers to the number of pulses generated per revolution. It depends on the number of slots or lines on the encoder disk. Higher resolution encoders have more slots or lines, providing finer position accuracy. Applications of incremental encoders. Incremental encoders are used in a wide range of applications, including motor control and feedback systems in robotics and automation, CNC machines for precise tool positioning and motion control, industrial applications such as conveyor systems, cranes, winches, material handling, and machine tools. Position sensing in medical devices, optical instruments, and scientific equipment. Interface control and position sensing in devices like cameras, printers, and audio equipment. Overall, rotary encoders are versatile devices essential for accurate position sensing, feedback control, and precise movement in radar systems, maritime operations, and a wide range of other applications across industries. Thanks for embarking on this technical voyage with Ship's Tech Talk. Don't forget to like, share, and subscribe for more insightful discussions on ship technology and beyond. Until next time, fair winds and smooth sailing.